Good day. My name is Neo Rasatello. This presentation demonstrates my research project titled Predictive IoT-enabled maintenance system for ATM networks using log-based anomaly detection models. So the purpose of this system is to monitor ATM machines in real time and predict potential failures using IoT sensors, cloud computing, and machine learning techniques. So this helps to reduce downtime and improve system reliability. So before I demonstrate the system, let me briefly explain the architecture. So the system follows a standard IoT layered architecture consisting of perception layer, which includes sensor installed in ATM machines, and also the network layer, which transmit data using communication protocol, and thirdly, processing layer, which include cloud computing for data analysis, and then fourthly, application layer, which provides dashboard and alerts as shown in the diagram. Data flow from sensors to cloud where it is processed and visualized. So this layered approach ensures scalability, efficiency, and real-time monitoring. So as you can see here, I've used for my simulation, I've used the Cisco Packet Tracer to come up with the simulation for this project. So I'm just going to take you on how the data is collected. So now I will demonstrate the system, how the system collects the data. So in the simulation, the ATM machine is equipped with sensors that monitor key parameters such as temperature, vibration, power status, as you can see here. So this is our MCUP, and this is the temperature and the power meter that I'm talking about. Also the vibration, which is your motion sensor here. And then this sensors continuously generate data representing the health of the ATM. For example, an increase in temperature may indicate overheating, while abnormal vibration may indicate mechanical faults. So the data is collected by an edge device such as ESP32 or Raspberry Pi. So once the data is collected, it is transported from the edge device to the cloud. The system uses the MQTT protocol, which is a lightweight communication protocol designed for IoT system. So MQTT works on a publish, which is subscribe model, where the device publishes data to a broker and cloud services. So this approach, it ensures efficient communication, especially in low bandwidth environments. So in this simulation, you can see how data is being sent continuously to the cloud platforms. So if I am to play this now, you will be able to see the movement of this. Although this is not completely done, but I've done the configuration to such a point that you can see the movement of data, how it moves from from your sensors to actually to the dashboard, where we'll be able to visualize everything there. You can see it's transporting the messages, and sometimes it's going to show you error there because the configuration is not completely done, but it will be done in the second semester. So yeah, when I continue with this, and then after the data is reached in the cloud, it is processed and analyzed. So the system applies machine learning models such as deep log or logbet to detect anomalies in both sensor data and system logs. For example, if temperature exceeds normal threshold, or if unusual patterns appear in the log data, the system identifies this as anomalies and flags them. So this enables predictive maintenance because faults are detected before system failure occurs. So this is the main aim. So we don't want to be reactive. We want to become proactive in our system. So next I will demonstrate the visualization layer, which here you can see that it's on the dashboard. This is where the monitoring of everything will be done there. So So as you can see, so the process data is displayed on a dashboard using tools such as Grafana, Power BI. On the dashboard, we can see real-time sensor readings, historical trends, alerts for abnormal condition. For instance, if an ATM shows abnormal vibration, the system highlights it immediately. So this will always this allows maintenance teams to take proactive action instead of waiting for a fail. So in conclusion, the system demonstrates how IoT, cloud computing, and machine learning can be integrated to enable predictive maintenance in ATM networks. So the system monitors ATM health in real time, detect anomalies using intelligent models, provide visual insight for decision making. So this approach improves system reliability and reduce downtime and lower maintenance cost. So yeah, I want to thank you for listening to me. So if I am to go inside of these things, I've done the configuration using this you know this is my microcontroller. As you can see, I've given is the IP address there, and you can see that this thing is working. So all these components are communicating together. They are communicating together. As you can see, the movement of messages in form of, let's see, it even show you the gigabytes and all that. So this is functional. So thank you so much for listening to me, and I really appreciate. And yeah, so we will complete this in the next semester for it to function correctly with the right components, live components, and all that. Thank you.